Today I'm here with Justin Powers, who's going to walk us through some cool technology. How are you doing today?
I'm great. How are you?
I'm doing really well.
Yeah, so what we do here is the VDC department takes the bid drawings or the design intent, and we just basically translate it into a workable, constructible, usable model, which is then used in fabrication, to bring it out into the field and install.
So the kind of stuff that we're looking at back here?
Yeah, so what we see here is we've got a little bit of an overlay, some modeled stuff, and over the top of a actual picture that just shows you how it went into the field and what it actually looked like.
So how did you start here?
So I started as a service apprentice, well, as a service guy, and then as a pipe fitter apprentice, and then just kind of worked my way through. I was a pipe welder for a little while, then became a foreman, then came in the shop just doing design work, learning how to use Revit, learning how to draw pipe, and our whole process just kind of evolved from there, basically.
Excellent. So you know literally every step of this process.
Yeah, I've done it all at least 100 times. So.
Okay. Well, I'm looking forward to having you explain a little bit more about that, and then watching it go from your desk to the shop.
Sure. Sounds great.
Great.
We put them in the model and we just work them together. Whatever's going to work, be able to actually install what will work right, how it'll fit. You think about all those things crossing each other, running into each other, maintaining service clearances. That's one of the things we really excel at here is we can see a service clearance on a chiller or a boiler, that way you don't run a pipe through it. We've got a digital representation of it, so you just miss it. You just run your pipe right around it. But we'll do it for this particular job here is we went out and we've got a 3D spatial scanner. We bring the scanner and set it up in the room, and it'll just capture literally millions and millions and millions of points.
Oh, wow.
So that's what you see here is an accurate snapshot of exactly what that room looked like, right? We've got this scissor lift in the room that probably drove out after, but we've got everything we need, so we can see the ceiling, we can see these columns, we can see tie-on points where we need to hit with pipe. So we'll take this and we'll create this model you see here. So this one here, we didn't have much to start with, so we basically created everything to match this exactly, right? So you can see the columns line up, and we're hitting holes in the wall and tie-in points and whatever. But all this stuff gets built digitally, turned into a sheet, and then that sheet goes out to our fabrication shop along with digital exports for cut lengths of copper, or digital exports for the pipe that we'll see later. It's got the holes already built into it. It's cut with a bevel on it. It's cut 32nd long on each end, so that way when it gets a land ground on the end, it's the exact right length every time to the 16th. So
this is really kind of debunking that myth that welders and welding is a dirty field. There's nothing dirty about this aspect of your job. This is really high tech.
Yeah, for sure. It really is when you think about how finely detailed what we're doing is. Like I said, we're accurate to the 16th to the 32nd. And we're working in a digital environment. You go out one time, get it, sit at a computer and build it once virtually before you think about what that was like in the field. Soapstone drawn on the floor and pencil drawings, and then reworking pipe, and you're right, it's cleaner.
Well, and also if someone's really interested in technology, there is a place for them in welding.
Kind of picked out a component to look at here, which I've got on this screen. So this pump here, what we've done is we've detailed it down to an isolation valve. We've got a valve for a differential pressure gauge, a strainer, all those little pieces, like I said, that are required to make sure that everything's right, down to the weld gaps, right? All that stuff's built in. And then what we'll do is we'll take this and turn it into a fabrication sheet, which we use in our shops with all the dimensions and things that they could reference later to make sure that they build it exactly according to the model. So when it goes out in the field, it just kind of all fits like a big fancy puzzle. So
all of these pieces will be sent to another building, and they will be cut to the exact specifications. They're going to be probably labeled, barcode.
Yep, barcode.
And then everything is just automatically, everything is automatically cut and it can be assembled?
Yeah, so then it turns into the skill out in the field then is the moving heavy equipment, learning how to erect everything, the welding, all those things, and then we just take the layout, the design work, all that hard thinking in here, and then the guy in the field is just left to do his actual craft work, which is nice.
In air conditioning or heat?
Out here, here,
your job is a little bit easier than it used to be.
It's different than it was, I was always on the roof in the winter, so this is different.
So Justin, what's this barcode for?
So this just tracks where we're at, what project, all those things. And like I said, we can take the iPad and we can scan. Once we scan, it'll bring up the sheet and tell us where we're at. So what we've got here now is we've got that actual sheet. We can see how far it is complete, where it is in the process. All those things we saw up on the computer all just kind of works its way down here to the guy who's actually building it, or the person in the field. If they find this piece of pipe, they can scan it and figure out where it came from, what job, where it actually belongs.
Wow, could you do that for stuff in our house?
That'd be perfect, wouldn't it?
So you can just always know where it is and always know where it goes.
Yeah, right.
Oh my gosh.
That'd be perfect.
Life hack. Okay, so our next step is to actually build the piece?
That's correct. Let's go do that.
Let's do it. As you can see, the piece is rotating on a positioner so that he can maintain the same position the entire weld. Okay, good? Yep. Are you sure this isn't a robot? Man, that's a good looking weld. Good job.
Thank you.
So I noticed that you were using RMD on that root pass. So what made you choose RMD?
Just the process itself is a lot easier to control and put in a root pass in.
Okay, and now what's your process going to be for the next step, for the cat pass?
The next step, we go strictly pulse, spray transfer pulse.
Okay.
Typically our settings, I like to do a little bit of a tight weave.
Okay.
Basically, almost like a nervous little shake weave pattern.
A little too much caffeine or not enough, right?
What's that?
A little too much caffeine or not enough?
Yes.
Yeah, I gotcha.
Yeah,
okay.
Either one.
So Alex, tell me, how did you get into all of this?
I started off in high school. We went to the Kankakee Area Career Center. They had a welding program there. I did 1 year there, and then I went to Kankakee Community College. Their welding program pretty good. I'm still really good friends with their program coordinator, Mark Stevenson. And then from there, I didn't jump right into the pipe fitter trade. I went to became a commercial diver for 3 years.
Oh wow!
And then I got into the trade. So, and ever since then, I got into the welding program through our hall and took off from there.
I noticed that people that work here tend to start off on the floor. In fact, it looks like everyone in management positions have been doing the job. So where do you see yourself in 5 years?
Oh boy. Well, it's hard telling.
We'll go 10 years maybe.
10 years.
Yeah.
Well, I mean, it's hard telling. The way this trade goes, I mean, I can see myself here, I can see myself out in the field. I like to think of myself as a pretty versatile welder, so anywhere they need me, I can go be and do it.
Excellent. What is your favorite part of welding?
Oh boy.
I know.
I like the challenge of it. I like trying new things. It's too vast of an industry to just say, like those guys that are like, oh, I've done it all, and it's like, no, you haven't. You know, there's just too much there. So I like that aspect of it, knowing that I could learn something new from it every day.
What do you think the hardest thing is that you've ever worked on as a welder?
The hardest thing I've ever worked on?
The most difficult challenge that you've had welding?
Well, that was the underwater. That was definitely a pain. It's not a good process. It's not meant to be a permanent anything. As soon as you light up, there's bubbles flying at you, so you can't see what you're doing. You're truly blind. I'd say that was hard. In the trade, however, definitely working on like steam and chrome. Those are, I would say, more of the challenging processes.
What do you think your welding skills and your knowledge have brought you besides just a paycheck?
Oh, well, I've been in the trade 5 years, 6 years, and I mean, these guys consider me one of the top guys in here, so I mean, it's helped me out.
Pride?
Understanding the actual science of the process definitely, I feel, helps me not only explain to other guys, but teach them, you know, about the process, because I'm also a welding instructor at a local hall.
Excellent. So there's science in welding? Wait, what? I thought that was a dirty job.
No.
Right?
No. There's a lot that goes into this than just squeezing a trigger or setting your amperage or, you know, or voltage or anything like that, yeah.
Don't you laugh when someone's like, oh, you're just a welder.
Oh, I love it.
And you're like, yeah, let me show you some chemistry and some physics, bro.
Yeah,
okay.
absolutely.
Every day.
Yep.
And geometry and algebra and everything else.
Yep.
So.
And on the fly.
Yeah, well, right, you have to think fast. Yeah, awesome. Well, thank you for your time. Thanks for letting us pop in your booth over here. And
no problem.
appreciate it.
Thank you.
Take care.
Nice meeting you.
Nice meeting you.